Recording is on.
Okay, can everyone of you see the screen? Can everyone see the screen?
Yes, sir.
So then let's today move on with molarity. Molarity. So in the last class, we had discussed about the weight by weight percentage. That means how much weight of the solute is present in 100 grams of the solution. Whereas we had also discussed about the weight by volume percentage, which tells us how much weight of the solute is present in 100 ml of the solution. So that was the weight by weight percentage and the weight by volume percentage. So today we are going to see about the molarity. What is molarity? Molarity is number of moles of solute dissolved per liter of the solution. So molarity molarity is denoted by capital M. So remember this, molarity is denoted with capital M. So what is molarity? It is the number of moles of solute, the number of moles of solute dissolved per liter of the solution. Dissolved per liter of the solution. Okay, so this is the definition of molarity. So this new unit of concentration that we are learning today is known as molarity. And how do you define molarity? It is going to be the number of moles of the solute that is dissolved per liter of the solution. So if we express this in formula, then how does it look like? Molarity capital M, that is equal to, see, number of moles of solute. So that will be in the numerator part. Number of moles of solute. Number of moles of solute. And in the denominator we have volume of solution in liter, because it says dissolved per liter of the solution. That means volume of solution in liter. So this is the formula for molarity. Number of moles of solute divided by volume of solution in liter. Now you might ask me that how do you calculate the number of moles? So what is this number of moles? How do you even calculate it? So number of moles means one molecular weight. We have already calculated we have already done how to calculate the molecular mass. So one molecular mass is known as 1 mole. Okay, one molecular mass of a substance is known as 1 mole. For example, if I tell you water, okay, suppose water. What is the molecular weight of water? What is the molecular weight of water? Tell me. What is the molecular weight of water? 2 plus 16, that is equal to
18.
18. So the molecular weight of water is going to be 18 grams. Okay. So that means one molecular weight is equal to 1 mole. So 18 grams of water, that is equal to 1 mole. Okay. Now, always in the laboratories or anywhere, we are not going to do the experiment with 1 mole only. We are always not going to practice our experiment with 18 grams of water. We might take more than 18 gram, or we might take even lesser than 18 gram. Then how do we quantify it? So just do unitary method. 18 gram is equal to 1 mole. So therefore, 1 gram of water will be equal to 1 by 80. Okay. And therefore, suppose if in the experiment you are taking 1.8 gram of water, 1.8 gram of water. So that will be equal to, just like unitary method, 1 by 18 into 1 by 8. So that is equal to 1 by 10, or you can write it as 0.1 mole. So this is how you calculate the number of moles. So 1.8 gram of water is going to be equal to 0.1 mole. Okay, is it clear how we are calculating the number of moles? One molecular weight is equal to 1 mole, and from there you do unitary method and get the number of moles. Is it clear to everyone?
Yes, sir.
And if it is clear, then you calculate and tell me, suppose if I take 2.2 grams, 2.2 grams of carbon dioxide, 2.2 gram of carbon dioxide, 2.2 gram of carbon dioxide is equal to how many moles? How many moles? So tell me, how many moles are there in 2.2 gram of carbon dioxide? Just like the previous method, tell me how many moles of carbon dioxide do you have in 2.2 grams? So first find out the molecular weight of carbon dioxide. What is the molecular weight? What are you getting by calculation?
44 gram.
44 grams. Okay. Then now do unitary method. So what is the answer? So you are getting 44 grams of carbon dioxide, that is equal to 1 mole. So therefore 1 gram of carbon dioxide, that is equal to
1 by 44.
1 by 44. So therefore 2.2 gram of carbon dioxide is equal to 1 by 44 into 2.2. So that will be equal to, this is going by 20. So 1 by 20. So that is equal to 0.5 moles. 0.5 moles, not 0.5, 0.05. 0.05 0.05 moles. So is it clear how to calculate the number of moles? Is it clear to everyone how to calculate the number of moles?
No, sir. Can you repeat from the starting?
From the starting of carbon dioxide?
Yes, sir.
Okay. So I am saying that 1 mole of a substance is equal to the molecular weight. A molecular weight of any substance is equal to 1 mole. So the molecular weight of carbon dioxide is 44. Molecular weight of carbon dioxide is 44. So that means 44 grams of carbon dioxide is a 44 grams of carbon dioxide. This is basically equal to 1 mole, because molecular weight of any substance is equal to 1 mole. So 44 grams of carbon dioxide is equal to 1 mole. So therefore 1 gram of carbon dioxide. Now we are doing unitary method. 1 gram of carbon dioxide is equal to 1 by 44. Now in the question it is asking 2.2 grams. So 2.2 grams of carbon dioxide will be 1 by 44 into 2.2. And now if you do this calculation, it will come at 1 by 20, which is equal to 0.05 moles. So it is unitary method. That molecular
How
weight,
1 by 20? It is not coming, I think.
it is not coming 1 by 20. It will come, see. If you can do this decimal, what happens? This one you multiply by 10, denominator also you multiply by 10. Ultimately this becomes 22 and this one becomes 44. 22 twos are 44. So this one will cancel out. 22 twos are 44. And another 0 over here, so 20. Or you can even do it by smaller ways of division. That is into 2, into 10, into 10. So this becomes 22 by 440, by 440. Now do all those cancellation. You can cancel them by 11. You know the table of 11. 11 twos are 22. 11 fours are 44. And
Yes,
0.
yes.
And
Yes.
then if you cancel out, it will come at 20. But
Yes.
here, because 22 and 44, you should just quickly be able to do it directly. Okay. So now is it clear to everyone how you calculate the number of moles?
Yes. Yes, sir.
Okay, what about the others? Is it clear?
Yes, sir.
Okay. So from here, you can come to a conclusion. That is, every time we cannot do unitary method because that is time consuming. That is taking some time. So every time we'll avoid doing this unitary method. So we can write it as number of moles is equal to what? We are getting the number of moles as, you see, in the two examples that we did. What is 18? 18 is the molecular weight of water. What was 44? 44 was the molecular weight of carbon dioxide. So that means in the denominator we have molecular weight of the substance. Molecular weight of the substance. And then the numerator we are having the amount of weight that we are taking. We are taking 1.8 grams of weight, water, or 2.2 grams of carbon dioxide. That is also coming in the numerator. So that means weight of the substance taken at the numerator. 1 so doesn't hold any significance. So we'll be not writing that. Weight of the substance. Weight of the substance. Weight of the substance. So number of moles is equal to how much weight you are taking. Weight of the substance taken. How much weight you are taking. Weight of substance taken divided by molecular weight of that particular substance. Molecular weight of that particular substance. So now suppose if I tell you, you are taking suppose uh, 8 grams of methane, 8 grams of CH4. So now use the formula and quickly tell me how many moles are there in 8 grams of CH4. 8 grams of CH4. So quickly calculate and tell me how many moles are there in 8 grams of CH4. Use the formula and tell me. What is the molecular weight of methane? What is the molecular weight of methane? CH4. Yes, so the molecular weight of methane is 16. So we put the value of denominator, molecular weight of the substance is 16. And how much you have taken? How much weight have you taken? Tell me, how much weight of the substance has been taken?
8 grams.
8 grams. So you are getting it as 1 by 2. That is equal to 0.5. Okay. So by the formula, you can do direct. And how is the formula coming? Formula is basically coming from the unitary method itself. By the unitary method only, we are coming to this ultimate formula. Okay. Is it clear to everyone? Is the formula of calculating number of moles clear to everyone?
Yes, sir.
So now let us come back again to molarity. This was the number of moles calculation. So now you are getting to see molarity is number of moles of solute divided by volume of solution in liter. Now this is the basic formula. Okay, this is the basic formula. Now what happens in exam, teachers will not directly give you number of moles. Teachers won't be directly giving you directly the number of moles. Rather, they will be giving you other data. So you have to modify this formula. Okay, so there are various alternatives to the formula. See, instead of writing number of moles, you can write it as number of moles can be written as weight of solute in grams divided by molecular weight of solute. So instead of writing number of moles, we are writing it to be as weight of solute divided by molecular weight of solute. Meaning we are simply substituting this formula. We have just now calculated the formula for number of moles. We are putting that only over here. Weight of solute by molecular weight of solute. Okay. Into the volume of solution in liter. So this one we are writing it just as it is. Volume of solution in liter. So this is the second formula for molarity. So this is going to be the second formula for molarity. Okay. Then let us see what else formula we can use. Now, weight by volume of a substance. This weight by volume of a substance, this is known as the strength. This is known as the strength of solution. So weight by volume, this part is together known as the strength of solution. Weight of solute divided by the volume of solution. This ratio is known as the strength of solution. So instead of writing weight of solute by volume of solution, we can modify it to another formula, that is strength of solution in gram per liter. In gram per liter. So instead of writing weight of solute by volume of the solution, we are writing it to be a strength of solution in grams per liter. As a gram is in the numerator, liter is in the denominator. So we are writing it as gram per liter. Strength of solution in gram per liter. and molecular weight of solute will remain as it is. Molecular weight of solute is going to remain as it is. Molecular weight of solute.
Sir, can you repeat the second formula?
The second formula once again. Okay. See, in the second formula, instead of writing the number of moles, we are just substituting the value of number of moles. See, we have just now derived this formula. Number of moles is equal to weight of the substance taken divided by molecular weight of the substance. So instead of writing number of moles, we are putting this over there. See, that only we have done. Weight of the solute in grams divided by molecular weight of solute. So this only together make up the number of moles. And volume of solution in liter, this was there only previously only. So that is why this remains.
Yes.
Okay. And then weight of solute in grams divided by volume of solution in liter. Together they are known as the strength of a solution. Weight of solution in grams divided by the volume of a solution in liter. Together they are known as the strength of a solution in liter. So we have written that divided by the molecular weight of solute. So this is yet another formula. Okay. What else formula can you use? See, we have different variation of formula. Now you might ask me that why are you having even so many formulas? We could have done it with just one. The reason for this formula is so many formulas are basically depends which formula we'll be using, that is dependent on the data that are given to us. Okay. Sometimes they might tell us the weight of solute, the volume of solution, all these things. Then we apply the second formula. Sometimes they might not tell us the weight of solute. They might directly give us the strength of solution in the question paper. So it depends from question to question what data will be given. So because there can be different orientation of a particular numerical, that is why we are learning up all the formulas so that we can apply them according to the set of data that is given in the paper. Because always the same set of data might not be given. Always they might not give us the number of moles of solute. If they give us, then so very nice. If not, then we have to derive to the other formula. Okay, and the final formula that you can write over here is always they will not give us the volume of solution in liter. They might tell us 100 milliliter, 50 milliliter. So instead of telling us the volume of solution in liter, they might tell us the volume of solution in milliliter. That can also happen. So then what? Then what do you do? If the volume of solution is given in liter, suppose they tell us the volume of solution is 100 milliliter. But now you see our formula is basically volume in liters. So you have two options. Either you convert that formula of liter, of milliliter into liter. Either you convert the milliliter into liter and apply the first formula. Or you can do another thing. That is, you can apply a second formula, an alternative formula. Now see that alternative formula is also basically the same thing. That is also the first formula only. That is why if you understand one formula, if you can understand one formula, then there's no point of remembering them. You can quickly derive these formulas in the exam hall itself. So if you are confident about the concept of each and every formula, then there's of no point of memorizing these formulas, because you can easily derive them in the exam hall according to the demand of the numerical. Okay. So suppose now they have given us the volume of solution in milliliter. And in fact, that is only the case, because in laboratories, you do the experiment with small amount, 50 ml, 10 ml, 100 ml. So milliliter is the preferred unit in labs. You do not do any experiment with 1 liter, 2 liter, all these things. 1 liter of solution, 10 liters of solution. No, we do not use such a high volume. We always use a small volume in laboratory experiments. So that is why this fourth formula is also important. In the fourth formula, the volume is told in milliliter. So volume of solution in milliliter. Okay. And in the above you have number of moles of solute. Number of moles of solute divided by the volume of solution in milliliter. Now see, these two formulas are becoming different because the basic definition is number of moles of solute divided by volume of solution in liter. So how do you convert milliliter into liter? Tell me. How do you convert this milliliter into liter mathematically? In maths, how do you convert milliliter into liter? Tell me.
Into
How do you convert milliliter into liter? We have done this conversion factor also in the first class itself. Anyone? 1 milliliter is equal to how many liter? Tell me. 1 milliliter is equal to how many liters? 1 milliliter is equal to 1 by 1000 of a liter. 1 by 1000 liter. So that means in order to convert milliliter into liter, you have to divide this value with 1000. You have to divide this with 1000. In order to convert milliliter into liter, you have to divide this with 1000. So what happens? 1000 in the denominator, this one will go up in the numerator, just like it happens in fraction. So at the top, you have to multiply by 1000 because it was initially in the denominator. So after calculation, it will go back in the numerator. So into 1000. So this is the final formula for calculating molarity. We'll be applying them depending on the necessity and the demand of the numerical that we are solving. Depending on the data that is given to us, we'll be applying any of the given formula. Okay. Are the formulas clear to everyone? The basic formula is the first one. Number of moles divided by volume of solution in liter. These are all derived from the first formula itself. So are the formulas clear to everyone?
yes, sir.
Okay, it is clear then. What about the others? To the old students who have already done it, do you remember these things? To the older students who have already done the chapter, did you remember these things or did you forget it? Okay, so let us see a numerical. Very easy numerical. Suppose calculate the molarity, or write it in this way. 3.92 grams. 3.92 grams of sulfuric acid is dissolved in 200 ml water. Calculate the molarity. Calculate the molarity of solution. So tell me, how do you approach this sum? To the older students, tell me, who have done it previously. Abhay, Ayush, are you there in the class? Abhay, Ayush, Papya, are you there in the class? Hello, are you there?